In the last class we have discussed a method to evaluate the principal value of improper integral, that is principal value of integral minus infinity to infinity f of x dx equal to 2 pi I times the sum of the residues of f of z which lie on the upper half plane. Suppose z1, z2, etc. zk are all singularities of f of z which lie on upper half plane. Then we find all the residues of those singularities and sum up all this and multiply it with 2 pi I. That will give the principal value. If this function is even, f of x is even, then obviously this principal value is same as the integral value. Now we discuss an illustrative example for this. We will evaluate an integral in an improper integral, that is integral 0 to infinity x square divided by 1 plus or x raised to 6 plus 1 dx. So in order to evaluate this function, we consider f of z first. F of z is z square by z raised to 6 plus 1. So this is obtained by replacing all the x's in the integrand, and we observe the singularities of this function. We know that singularities of f of z are obtained by equating the denominator is equal to 0. This will give the sixth roots of minus 1 are the zeros of this polynomial or this denominator. So that will give the singularities of f of z. So obviously this z can be written as, that is the sixth roots of minus 1. So we first express minus 1 as a more or less argument form, that is 1 times e to the power I pi. In the general case we write this as e raised to I pi times 2k pi, and in order to get the sixth roots we divide it by 6. This k varies from 0, 1, 2, 3, 4, 5. So these are the 6 distinct sixth roots of this minus 1. Now we name these numbers as c0. That's the first one, that is obtained by putting k is equal to 0 here. So that will be e raised to I pi by 6. So that's the first one. And second one, that is c1. c1 is obtained by putting k is equal to 1 in this expression. So that will be e to the power, by putting k is equal to 1. So this becomes pi plus 2 pi. So that is 3 pi. So that is 3 pi by 6. 3 pi by 6 is nothing but pi by 2, I pi by 2. So this will be I pi by 2. And c2 is obtained by putting k is equal to 2. When we put k is equal to 2 here, so this will be 4 pi, then 4 pi plus pi, that is 5 pi. So that is 5 pi by 6. So that will be e to the power I 5 pi by 6. So this is obtained by putting k is equal to 2 here. So these are the singularities. Now we can write 3 more singularities for this function, but all those are in the lower half plane. So we need to consider only these 3 values, these 3 singularities which lie up on the upper half plane. Okay. So first we evaluate all the residues of these singularities. Then that is residue at if you put residue of this function, that is z is equal to some ck. So these are c0, c1, c2. We generally evaluate all this f of z. So we know that this since these zeros are zeros of this z raised to 6 plus 1, and we know that this z raised to 6 plus 1 can be expressed as a product of distinct linear factors. So these are all poles. So since these are all poles, we use the formula to evaluate the residue, that is f of we write this as f, this z square. We know that z square by z raised to 6 plus 1, that is our f of z. So in order to evaluate this residue, we write z raised to we evaluate this ck square divided by the derivative of this, that is we evaluate the denominator derivative numerator at the point ck, so that will be 6 times z raised to 5, that is ck raised to 5. So these are the residues at ck. So by putting k is equal to 0, you will get you need to substitute these c naught first, then that will be that this is in fact 1 by 6 times 1 by ck raised to 3. So for k is equal to 0, 1, 2. So these are the only singularities on the right hand and the upper half plane. So this will give in fact for any value, if you put this k ck as this one, then ck cube, that will be we can evaluate this for k is equal to 0 first. So k is equal to 0, we will get this value is equal to e raised to I pi by 6 square, so that is this square divided by 6 times e raised to I pi by 6 raised to 5. So this is in fact 1 by 6 times 1 by e raised to I pi by 6 whole cube. Okay, so this will give 1 by 6 times when you find the cube of this, you will get e raised to I pi by 2 in the denominator, so that will be I. So this is 1 by 6 times I. In similar fashion, you can evaluate this for k is equal to 1. K, for the case k is equal to 1, we put ck as the ck is equal to this quantity, then 1 by 6 times whole cube is here, so that will be 3 pi by 2. So 3 pi by 2 is again minus I, so that will be the residue at that point. So this is in fact the residue of z equal to c naught f of z, and residue of f of z is equal to z1 will be by putting c1 here. So that will be, we just put c1 in this expression, that will be 1 by 6 times 1 by c1 is this one, so whole cube, that is e raised to I 3 pi by 2, 3 pi by 2, so that will be minus I. So 1 by 6 times minus I, so that is this one. And for k is equal to 2, so that is the last one, that will be residue of z, f of z at z is equal to c2, this one, that is 1 by 6 times again 1 by ck cube, that is c2 cube. c2 is this one, this whole cube is again this 5 pi by 2, so that is e raised to I 5 pi by 2. This is in fact e raised to I pi by I 5 pi by 6 whole raised to 3, so that will be e raised to I 5 pi by 2. So this will again, this is in fact this e raised to I pi by 2, so this is again 1 by 6 times I. So these are the three residues. Now you write the integral integral 0 to infinity x square divided by x raised to 6 plus 1 dx. This will be 2 pi I times the sum of the residues, that is 1 by 6i, 1 by minus 6i plus 1 by 6i. These are the residues. So you will get the value 2 pi I times the sum is the first two term can be cancelled, then you will get 1 by 6i, then multiply it with 2 pi I, then you will get 2 pi I times 1 by 6i, then you can cancel this 2, then that will be pi by 3. So this is the value of this integral. So this is the way we evaluate the principal value or integral value of improper integral using residue theorem. So this is our last video. So with this we can conclude our syllabus in the 4th module as well. So there will be some exercise problems are given in the textbook, so please go through it, and if you have any doubts we can clarify through live classes or WhatsApp communication.